So we're going to change the Pathfinder, and actually we're going to use the A-Star Pathfinding project, the Pro version. There is a free version as well, but I just like the Pro version, and I just like this so much that I've actually just stopped writing my own Pathfinders anymore. I just use this now, to be honest. It does a really good job. It has a lot of options, so yeah, I think just invest a little bit. It's not even that pricey anyways, and yeah, just buy it, and it will save you a lot of time for a lot of different types of games, which is actually the best thing about it. Okay, so I've already imported this into our scene. Now we already have where we want to where we can walk. That's a little teaser for you on the right. See if you can find who it is. And yeah, and we kind of don't want to throw this away. So I'll give you the first problem that we're going to have. First of all, I'm just going to add the Pathfinder. And let's make this 000. And the first thing you're doing is you'll add the Pathfinder script, and you end up with this. So I'm going to add a grid graph, and this will give me, first it won't give me nothing because we have to tick to 2D, and this will be now our, this will be now our 2D graph. Let's move this on the side. Okay, we can conform this to what we need, and we kind of need to make, however, the nodes a little bit smaller because we don't have that big of a size anyways. So let's make this to give us 100 nodes on the left and right. You see that that's not too much so far, so let's do 150. We don't have to be that precise, we can just go higher and higher. Okay, so we'll go to something about like this and 20. Now if we click scan right away, you will see that we're actually not getting any results back. So why that is? We kind of need to fix a few things. First, we need to say that we want to use, well, we don't really need collision testing, and we don't even need height testing. So if you scan now, it will basically say that everything we have onto our grid is walkable. Of course, that's not really the case for us. So you can enable 2D physics and then collision testing, scan again. We actually need to set a layer mask. So I'll just say the walkable mask. And here's what we're going to get. We are actually getting the inverse of what we want because it treats as not walkable everything that we have said so far that is walkable. So that's kind of a problem. And that's the first thing that we're going to fix. But there is a way to just fix this. Onto by code when we start, so we don't have to bother about, scanning beforehand and all this stuff. So let's ignore this. We don't want any collision testing, we don't want to do physics, we don't want anything. Now what we can actually change is the type of the grid. So instead of a grid square based, you can just do hexagonal like this and then give it some rotation. It all has to do with how you want to be, you will want this to behave around corners and around edges, to be honest. Okay, let's give this some bigger value then. Let's do 200. Let's assign 2D physics, and let's scan to this. Okay, so it all has to do how you want the AI to behave around these edges. Okay, that's the only difference. We're not going to be going from one node, from the center of one node to the other center of the node. We're still going to be freely moving inside a grid. So you don't have to be that precise, and you don't have to have really too small of a width. Okay, just have enough so the AI can reach you whenever, wherever it wants to reach you. And yeah, that will be fine. If you want to use the grid, it's fine as well. I think even just with this, we should be fine. Okay, so the first thing we're going to do, because we still want to keep the, let's make this 3D icons. We still want to keep the base collider because both our player moves with this, and because we're pushing the AI around, we don't want them to be forced to just stay wherever the grid is. Okay, so we're still going to be setting up our level with the polygon collider we have over here, but we're just going to force the AI to move with upon the grid we have set it up for it. There is also some more benefits to that, but we'll see them later. So we could just make an AI come from over here without, with blocking the player to just come from over there. Okay, so we will have a lot more control than we ever could with the polynav nav object, whatever it was called. So the first thing, however, we need to do is to actually make our Pathfinder be able to sample the correct positions we want. And what are those correct positions is basically any collider or any walkable area that has the T walkable trigger onto it. Okay, so yeah, we're going to remove the polynav 2D. We're going to actually remove it entirely. We don't need it. We're going to change our AI as we go. So let's go and write a new script. By the way, let's do this under the utilities, and let's create a new script which is inverse or sample better Pathfinder. Now we're going to use some specific API for the Pathfinder project, but we should be fine with this. If you get the Pro version, then you can be sure that you won't need to write anything different, or you wouldn't need to try anything different than what I'm doing over here. Okay, I'm going to include the pathfinding namespace, then on awake or on start or whatever. Okay, we just need to be doing, if you write a star path active data grid graph, you actually get your grid. Okay, so that's basically doing half the work for us. And let's do var grid grid path. Let's put a layer mask so we know where to cast this. Layer mask, walkable layer. Then for item in grid nodes, we now have an array full of nodes. We don't need to be doing much. We're just going to sample if we can work on this or not. And we can squeeze some more performance later if we want to from our unit controller as well. So we could be looking from our player if we are, or if the position we are in right now is actually part of a walkable node. If it isn't, then you can walk there. If it is, then you can walk anywhere inside a node. Okay, really easy, really simple. You get some more performance, but I'm not going to do it because I think it's pretty light of a game anyways. So I don't really care to make the most optimized thing now. I just want to make just a fun game. Okay. Don't be the cult that is always wants to be optimizing. So enough, and we can actually just steal some code we have from here because we are already sampling if there is a walkable node where we want to move. And let's see where we have this. Okay, we're doing an overlap point all on the walk layer. I don't even think we need to do an overlap point all at first. You could just do overlap point, but yeah, we do this so we can have blocks and obstacles into our level. So okay, we will need this. So let's copy this. We're going to have to change it slightly or a lot. So we'll see it one by one. So for each item we have, let's make this a collider. And for each item which is a node, in our case, we're going to do an overlap point all on the walkable layer from the node dot position. Here's the thing, and if you read below what it says, position of the node in wall space, it tells you that the position is stored as an int3, not a vector3, and the simplest way to do this is to basically cast it as a vector3. Now, the reason for that is because in the Dark Ages, quote unquote, okay, we didn't have the vector3 integers. So this, yeah, I'm assuming this was written on, it's actually a very old plugin, to be honest, which is a plus to it because it means it can support a lot of different things and it's not relying a lot on the Unity version to do things. Okay, so that's much better. So in our case, just remember when you want to get the position of the node, you just cast it first to a vector3 and that's it. So we're going to sample all positions we have for a walkable layer. Now we don't need any of this, we just need to be checking. Let's put item to this one, why not? So we don't really need to be knowing if it's an AI or not, we just need to see if it's blocking movement or not. So if there is a walkable node, then it's valid, it's going to be true. Okay, we don't need any of this. So if we have found a walkable collider, or well, a collider that has the tag walkable component on it, that means if it's valid, or well, actually we don't even need to say if it's valid, we could just say node.walkable equals is valid. Okay, that's it. So with that, we have basically sampled our Pathfinder. The only gotcha to this, which is not really a gotcha, is that this runs on start. So any AI you want to spawn in that will be using the grid graph or anything like that, okay, you just need to spawn after this has worked. Okay, which is basically one frame later, which is more than fine. So we'll just put in the sample Pathfinder over here and we'll change the cast layer to walkable and that's it. So let's move the game view down here and I'm going to click to press play. So we see the result of it. Okay, and that's pretty good enough. We can actually just disable and not show the, let's do this out of play mode. So we can actually just disable, well, path logging I'm just going to set to none now, but just know it doesn't show the, it won't show some stuff over here. Like, I don't really care to see the process it took. Yeah, I know it's pretty fine. Another thing that we can do while we're here is basically just set up this to automatic low load. You can see that on my machine it can use 6 threads, on high it can use 12. It's fine, just low load. I think even if you just set this to 1, for this type of game you won't have any problems, trust me. And you can also do scan. I'm just going to leave scan on awake and path logging will do, let's say, no, none. Okay, and I'm just going to untick show unworkable nodes. Okay, and you can say that we now have where we can actually walk to, which is pretty close to what we had already. Only issue is this these corners over here, but we can actually just rotate the pathfinder till we hit the correct position we want to. Like, you probably can set this to 30. No, the 5. See? Yeah, you can even do this if you want, but I think it's just too much. Maybe we'll just use a grid with 0 rotation. Okay, so it will just introduce the on the edges. It will introduce a problem on the edges instead of, and you can say that I just change the grid and it will still work. Okay, so you'll have this over here, but you can tailor it as well. Fine. It's only the AI that is going to be going in here, nothing else. So if I wanted to add an AI, well, of course, I'm just going to add a simple AI now. And on the next part, we're going to tailor this into something more advanced. Okay, I'm going to close all the phases because I don't really need them at the moment. And let's take one of these tags, put him in here. And I'm actually going to close. Oh, we don't have much into this actually. So, okay, we'll keep that. Then all I have to do is add a seeker, which is what is used for the, for the Pathfinder, to access the Pathfinder actually. So then we can add either a rich AI, we can add a LERP, AI LERP, we can add a simple, actually if you go to pathfinding AI, you have 3 of this. Both of them, all 3 of them, well, because this is 2D, you only have to choose between AI LERP and AI path. That's all the changes you have to do. AI LERP is the simplest one. AI path is a little bit more advanced. Just change the y-axis forward so it's a 2D game, and you can change the radius. You change from here. You see that we kind of have to offset them a little bit, slightly up, or bring this guy down, but although I think we are doing this anyway. Okay, so if I wanted to add now a destination, you can just use this one, and I'm going to link in the target. Now you can also add a raycast modifier, and you change this to use 3D physics or just graph physics. Graph raycasting means it will go node to node, and physics raycasting will mean it will just skip everything until it finds an actual box collision or an actual collision. Okay, so just hitting play, you will make this guy move and try to follow us. Oh yeah, before you do that, you need to disable the gravity, because this is also using gravity, and because we are on 2D, because we don't need that. There is also rotation we don't need, because we are 2D game. Okay, and we close that. So you can see that it can now walk around. It's fine. Now, this, however, doesn't mean if I make 5 of these guys, doesn't mean that they are not going to be walking on top of each other. Which they do, as you see. So that actually didn't solve our problem. If anything, it created a bigger one. So, selecting all of this and adding the RVO controller, because we have the RVO controller, we now need to add, as you see in the warning down here on our Pathfinder, we need to add the RVO simulator. And we need to change the plane to XY, not XZ, and you can set up worker threads, you can set up anything you like over here, but you can read in the manual, see which one you want. And you can see that it actually starts to break them up. I still think some are already clipping between them, because we had a lot more, but if they start spawning in some different positions, this should be more than fine. This is just a stress case anyway, and if you are worried about how much you can have, trust me, you have nothing to worry about. Let's close this one. And you can see that it still has to do with the radius, of course, but you can see we don't really have to worry about anything when it comes to if they're going to overlap or anything. We're going to tweak this a little bit more, and of course we have to add all this into our own AI. But yeah, you can see this is working. You can see then that they actually have some form of velocity and they are being pushed around. And I think one way to fix this will be to just go on the AI path and just tick constraint inside graph. So that technically should make it so they are really constrained inside it. Okay, so now even if they are being pushed, they are always inside the grid, which is more than perfect for our case. I think it's, yeah, I think that's all we're ever going to need, to be honest. You can see that it performs nice. This, it's already a lot of things inside the, a lot of AI inside our map. So I don't think there's a scenario that we're going to be using this many, but you know, feel free to experiment, because this looks really fun and really nice. Okay, I see someone flying through them, and I think it has to do, like, if you notice this guy, there's always one that seems to be going much faster than the rest. and he doesn't seem to be caring that much about the collisions. But anyway, that's a small. I don't think there's ever going to be an issue with what we want to be doing with this. Okay, so yeah, I'd say it's a good spot to finish this. There's also other ways to use this. Instead of an AI path, you can actually add the AI lerp to this, and it will behave almost the same. You don't want rotation, and the AI lerp now, I think it's already constrained, always constrained on the, yeah, it's always constrained on the grid, so you probably don't need to worry that much about it. I don't know which will perform better, but I don't think we had any issues anyways with this. Now that this has to do with, okay, yeah, the AI lerp, you can see it's because it's lerping from position to position, it doesn't actually, you can see over here, it doesn't actually uses the RVO. Okay, so that's good to know. So that means we are really only left with one option, which is the AI path. Let's set this up again. Y-axis. Actually, we don't even need to set this up because we're going to move this. Okay, gravity no. Just for good measure, let's hit play and let's see it moving. And we've changed the radius here. That's actually fun animation. Fun to look at. And once we take constraint inside the grid, you can see that it just changes everything. Okay, so that's it for this part as well. So on the next one, we're going to start refactor. Well, it's not going to be a cool refactor that much, but yeah, we're just going to change our logic a little bit here and there, and we're going to hook this path animator because it's going to allow us for more flexibility down the line, down the road. Because with just this, it's also really easy to set up the bosses and set up behavior around the screen and so on and so on. Okay, so as always, you know what to do. Like, subscribe, and if you like to see more stuff, more videos, more series, more things like this, I'm actually curious how much more we can add without breaking bank. Okay, now we have dipped in animation, but it's also because we're drawing the gizmos and we are not actually putting a limit on our FPS. We should force a 60 FPS limit at least. Okay, but that just seems like it's performing pretty fine. So maybe we can use this to make the robots, the small robots or something. We'll see. Anyway, I'll see you on the next one. You know what to do. Like, subscribe, the Patreon thing, or the other thing, or any other way you can see it supporting this kind of projects or this kind of lessons and all of this. And I'll see you on the next one.